Hey guys, welcome back. In this video, I'm going to show you what we're going to learn as shallow and deep copy. So in this particular program, we have case 1 and case 2, where it is pretty much the same thing. I just show you in case 1 that there is a simple list, and in case 2 that there is a nested list. That is the only difference. And the reason why I show you this is basically in Python, we want to see how copy and deep copy works. Copy as in shallow copy. So if we in this program, if we see and we hover around the copy module, which has been imported from the copy function that has been imported from the copy module in Python, we just control and click if you're using Windows 10 or 11 version, and command click if you're using Mac, and we click on that and we come to the Python framework of shallow copy, where we have right here a definition that says shallow copy operation on arbitrary Python objects, which has been created by Python developers for developers such as us, so that we can use these functions from these modules, right? So in this program, we have in case one copy.copy function using a variable original that is containing a list into the copied variable, right? So these are pretty much straightforward, that it prints the memory addresses of each original and copied lists. And we see the first uh, important statement is that we are assigning a number to and changing the number from the original list, but whether we see that in the copied list or not is what we're going to learn, right? So let me just execute this, because on executing this, I can explain even better from the output that we see in this program. So we are taking the last four digits. We see a lot of numbers right here, but don't be intimidated. These are just the memory addresses. The actual memory addresses that is been held by the heap memory, and that heap memory is present in your RAM, which is the random access memory in your system, right? So here we see the first statement written as the original and copied addresses are false. That means that when we had written copy.copy function, this method basically copies that original list, right? But the only difference is that we are not directly taking it from that memory address. We are creating another memory address, right, in the heap. So original 123, the list contains a certain memory address, which is 2144, considering the last four digits, right? Now after the statement, now it takes copied variable which contains the same contents, right? Original and copy have the same contents. The only difference is that it has a different memory address. It is just like I take a pen from you. You have a particular pen, right? It is a Parker pen. Now that Parker pen belongs to you. Now I take a copy of that same Parker pen, I clone it, and I take it. So you have one copy, right? And I have one copy of that pen. So that pen belongs to you, and this pen belongs to me, the copy, the clone, right? So it belongs to two different people. So those people here are considered as the address, right? So it's as simple as that. And the statement here says that it has two different memory addresses. It's pretty much straightforward. So we print each and every single index, the memory address of each and every single index right here of copied and original lists, and we check that it is the same. 0192, 0192, 0224, it's all the same, right, for the original and copied lists. Now after we make the change, we assign 111 to the first index of the original list, not the copy list, the original list, right? So when we do that, now copied list will have this list 123, and the original list will change from 1 to 3 to triple 1, comma 2, comma 3, right? Now, the original and copied lists are different, no doubt. Earlier, it was 2144 and 1824. 2144 and 1824. There's no difference in this. It was different earlier, right? Because this is the outer list. Now the inner list will change. This is what we are going to check next. Now the inner list, earlier it contained 0192, right? And after I changed this uh, index, the value of this index from 1 to triple 1, it changes to, from 0192 it changes to 3712, right? But the copied list, which is stays unharmed, remains the same, 0192 0192, right? Now in the second case, I just uncomment this to show you what's going on here. We work with a nested loop, right? So I'll just clear this and show you what I've done here. Now working with this nested list, now what shallow copy does, let me tell you in advance, that it changes the outer loop only, right? So earlier, if I printed it correctly, we can see earlier it is 06560, right? The original list, and the copied is 6752, right? And the first index of the first list, right? That's what we are changing. For example, the first index of the first index of the first list, right? Which assigning that to 999. Now what we see here is 2864 of the first list. Now the outer list will remain unharmed. 1 8 888 1 8 888 right? Even after the change, the outer list will always, the inner list will always remain unharmed. Only the outer list memory address will change. As we have seen here, the outer list, that is 6560 of the original list, and copied list is 6752. Although it remains the same, the contents remains the same, right? Now after we have changed the value from 1 to 999, we see here that even the copied changes, the first value of the first thing. Why is that, right? This is what we want to learn. So what shallow copy does, it just copies the outer memory address, not the inner memory address of the inner loops, of the inner lists rather, right? And why did it change? We only changed the outer, the original, we didn't change the copied, right? So why did the copied one also take that change? That is because we see here that what is the address of the first index, 2864, and what is the same as in copied list, 2864. So basically when you are assigning this value 999 to this index, right, and you see that the memory address is the same, that means what you're asking, what you're basically saying is that I am going to replace this pen that belongs to you with another pen, right? Now I have a copy of that same pen because that pen also belongs to me. I did not make a clone. I may have made a clone, but what I'm doing is both the copies belong to the same address. Now we live in one community, right? Now this number is the community, 1 8 8 8. This is the community, but the pen is the same, which belongs to you and me. So since the memory address is the same, 2864, when we are assigning this 999 to the same memory address, so it is bound to change in both the original and the copied. And right here, it's 2864, it's 2864, right? And these memory addresses remain unchanged. All right, so what happens in deep copy? So this entire program is just the same. I have just changed the deep copy function in the copy module, and likewise if you just click on deep copy, and it shows us the entire uh, documentation that the Python developers have built for us. So coming back, right here we have the same implementation. It prints out the original and copied IDs, or memory addresses of original and copied, and it is doing the same functionality. It changes the first index of the simple list of only the original list right here. And in the second implementation, which is currently commented, and we see that it's a nested list, just like what we had seen in the shadow copy, right? So we want to check, or we want to see what happens, what is the implementation behind this. So if I just show you, the left side of the terminal is basically executing the first case, and the right side of the terminal is executing the second case, that is, which is currently commented out, right? So I'll just hide this for now and show you that in the first case, where I have taken a simple list, right, and done a deep copy of it, it shows us that it changes the memory address of the list, no doubt, right? But the inside contents, they don't change unless they have a list inside. So earlier the address of the first index was 4368, 4368. Why? Because these are the indexes, these are the elements of that list, not the list, not the list inside the list, right? What deep copy does, let me tell you in advance, is that if it changes the outer list, it changes the inner list too, not the inner contents. Only if it considers to have an inner list, only that list's memory address will change, not the contents of the inner list, right? So right here we have 4368, the content 4368, the memory address remains unchanged. Now we have the copied as 123, and this has changed. Why? Because we have changed it internally right here, right? After we have shown the entire list of memory addresses for each, we change the original, and we showed right here that this is the uh, replacing of the first index with triple one, right? And we've shown you that this is changed, the list has changed. Now the ID of the original will still remain unchanged, 2080 2080, and copied will be 1760 1760. So the outer list remains unchanged, although both of them are different from each other. The contents will be the same, right? Now after you have made this change of assigning triple one in with one, what we see here is that the first index, that is 7888, has changed, right? Now this is 7888 is the address of triple one, and the address of 1 in copy list is 4368. This was bound to happen, right? Because you're changing the entire list, you're changing the entire value of in that list, within that list, right? So it will definitely point to a different object in that heap, right? Now moving to the second case, where we see, I'll just hide the other one and I'll comment this out. I don't want to comment out the import because we are still using the import module right here, right? We are using an double list, a nested list, and this is the main uh, important note right here which I need to speak on. And right here we see that 4656 is the memory address of the original list, and the copied list is 4848. That is bound to change. This is what deep copy does. It changes the memory address. That means it is currently pointing to a new object in the heap. That means we have copied this list, right? This list, this original, and right now this list is present in another object in that heap, but containing a different memory address, that is copied, containing this memory address, but the contents are the same of original and copied. which is this particular nested list, right? So inside that list, we see the first element 8032 and we note it down as 8032. It remains unchanged. Why? Because we haven't made any changes yet, right? Now, after making the change, we assign, that is in line 58 right here, we assign 999 to the first list, first index. That means we assign it to first list, first index, that is index 0, that is containing the value 1. So instead of 1 right here, we will see 999, comma 2 for the first list, and the second list will remain unchanged. Now what happens here, what we have studied in um, shallow copy, that the memory address changes, right? Because the memory address was the same, both the changes we see in copied as well, but in deep copy we don't see that change right here. And that is because what deep copy does, it changes the outer list, no doubt, but have a look at the inner list, that is 9984, and the inner list for the copied is 4352. Now this is the very reason why, since the inner list is pointing to two different memory addresses, deep copy now sees that now I am entering this list and copied is entering this list. So when we are seeing that we are only changing the first uh, index of the first list of only the original, since the first outer loop, that is the outer loop, that is this one and this one right here and right here, this is the same. So we will change the memory address of this on deep copy, and we will also change the memory address of the inner list, that is this and this. So since we have changed the memory address of the inner list, it no longer remains the same. So that is the reason why when we change the original, it does not hamper the other list, because the list's memory addresses are not the same, they are different. So when you change the original, it does not reflect on the other, right? So this is what deep copy is. And we can see the very proof right here, that earlier one contained 8032 memory address, and right now it contains 0960, right? And for the copied element, it remains 80332, which we had earlier in the original 8032, which does not change. Why? Because the memory, the outer of considering this to be the contents, the outer list, that is this 9984, we are referring to 9984 to the inner list basically, not the outer list. And this is different from the copied. That is the reason why we don't see the reflected change, we don't see the reflected changes on the second copied list. That is 999 does not get copied to the copied list. So if you are interested in such simple topics, I would say it's not very difficult, or this is the basics of Python. We must be using this in projects, and I will show you more on shallow and deep copy as soon as I create more projects. And if you're interested in such videos, stay tuned. I'll see you on the next one.